final section of chapter 9 is all about parent functions. Okay, so we're trying to figure out what are the different parent functions. This section really sets us up for the rest of the year. Most of the functions we talk about here will be covered more in depth in later on chapters. Okay, so the 5 functions we cover show up again. Okay, and so that's why we take a really basic first quick look at them. First of all, parent function. A parent function is the simplest function that has the characteristics of that family. So it's the simplest function with the defining characteristics of that family. It's the most basic function that has the same graph as a bunch of other functions. Defining characteristics of that family. All functions in the same family look the same. Okay? They just have been transformed a little bit of our particular family. There are 5 parent functions. Okay, they're all listed in this nice little chart on page 67 that you can always reference as well. But here they are. The first one is the constant function. The constant function is a horizontal line. Its equation, since it's a function, we'll write it in function notation, is f of x equals c. Its graph is a horizontal line. Okay? So that horizontal line is a function. It passes the vertical line test. A vertical line is not a function. So when we talk constant, we're talking horizontal lines. Okay? Next one is a linear function. A line. Right? A line that you would graph using slope-intercept form, words like that. The most basic one is f of x equals x. It's going to have a slope of 1 and a y-intercept of 0. Any other slope would be a transformation. Okay? The third one is a quadratic function. You should all know what a quadratic is, but we definitely study it more in depth later on in the year. Quadratic function is x squared, x times x. We already talked about that a little bit when we did some of those squares in the square root section. Graph of a quadratic is a parabola. It's a U-shaped graph. Okay. Fourth one, cubic function. F of x equals x to the third, x times x times x. No. There we go. The graph of this one is kind of an S shape. Looks something like that. That's the most basic graph. Now, different variations of it will be transformed to look different. Final one, definitely have already talked about this one once this year, just not in function form. We'll save that for chapter 8. Is the square root family. F of x equals the square root of x. This graph has a little bit different shape. Some of the domains and ranges. For a constant, the domain is all reals. The range is just c, just that number. Linear, domain is all reals, range is all reals. Quadratic, domain is all reals, range is y is greater than a particular number. We'll talk about that when we get to quadratics. Cubic, domain is all reals, range is all reals. Square root, that x, the number underneath or inside the radical, has to be greater than 0. The range, whenever you take the square root, you always get a positive number. And so with that, your range will always be greater than 0. All numbers greater than 0. Okay? That's for this most basic one. As we transform things, the domain and range also change. Okay? So, let's look through some examples. We need to identify the parent function and the transformation of that function. So what is the parent function? And then what did we do to that function to get to what's up on the board right now? So the first one says g of x equals x minus 1, that quantity, to the third power. Okay? So whenever we see something to the third, that is our clue. This is a cubic function. That means the parent function is x to the third regular. Okay? Just to get yourself started, first I want you to push pause, and I want you just to come up with the parent functions for each one of these. Ready, go. Okay, check your work. The second one should be linear. It's just regular old x. Third one, quadratic. Got that squared. That tells us it's quadratic. Fourth one, square root. Look at that square root. It's probably not drawn very well. We probably should have the top of our square root going all the way over. But you knew it was square root. You're smart people. Last one is linear. Now, the last one looks a lot like the most basic linear, except for there's a negative. Your slope is -1. Okay, that answers half of the question. The other half says, explain the transformation given. What transformation makes these graphs different from the regular parent function that we identified already? To do this, the best way for you to do this is to graph the parent function, I'm going to call it PF, and this function, both of them, on the same graph. You have graphing calculators, I hope. You can plug both of them in and it'll graph them together, and you can kind of see how that looks. Graph them on the same graph. Plug in x to the third and x minus 1 to the third. Get them both plugged in, and then see what happens. Okay, if you don't have a graphing calculator, go on the textbook website and give it a try. Pause this, see what you can make happen. Okay, so let's take a look at that first one. As you can kind of see, we have an x to the third plugged in, and we have x minus 1 to the third plugged in. When we hit graph, it's going to draw the 1, x to the third, that parent function first in red, and then it redraws the second one in blue. So you can definitely easily compare. Now you have to answer what transformation has occurred. Okay, in this case, the graph has translated. It's just been slid. Not stretched, not compressed, not reflected. It's just been slid. So this is a translation. Okay, let's look at that next one. We need to change what we were graphing. We need the linear function as the parent function this time. And then x minus 3, that is our new function that we want to compare it to. So let's graph. Okay, this one looks like it's just been another side. It's not reflected, it's not stretched or compressed. It's just been grabbed and moved over. Grabbed and moved over. This is another translation. This one has been translated 1, 2, 3 units. It's hard for us to tell whether it's gone 3 units up or 3 units down. Or excuse me, 3 units to the right or 3 units down. And so as a result, let's just say translation 3 units. Okay? So let's just say that we have a translation where it's translated 3 units. Okay? How are you doing so far? You 2 for 2? I really, really hope so. Okay, let's look at that third one. The third one says x squared plus 5. Our parent function is x squared. The actual function that we are comparing it to, that has been translated, is x squared plus 5. Hit graph. Okay, look at that, 2 parabolas. Hard to see it all, right? Let's zoom out a little bit. Zoom out. Zoom out. Zoom out. It's really hard to see when it gets really, really fine like that. But we've moved our graph up 5 units, right? If we zoom in, get back to where we were, look where we started, and then look where our new graph is drawn. Okay? Our graph has done a translation up 5 units. Here it's pretty easy to see that we're going up. So let's clarify that and write that in our answer. Translation up, since we know we moved up 5 units. Translation 3, not 3. Come on, sister. 5 units up. Got that square root happening here, people. Square root of 4x. This one right here, I'm going to have to clear it out, but there is a square root button on this calculator, just like there's a square root button on your calculator if you're using an 84. If you're trying to use your 84 and you're stuck, no worries. Oh, shoot. No worries. Come see me in class tomorrow, and I'd be totally happy to make sure you know what you're doing graphing. Okay? Close up those parentheses so that you know what's going to graph right now. I have these switched around. I kind of screwed the pooch on that, but it'll be okay. We still know how to compare it. I'll even change the colors so that our new function is blue and our old function is red. Okay? Look at that. Look at that blue one. That blue one is up here now. They started in the same spot, but the blue one grows faster. It has been stretched out to grow faster. Okay? So we have a stretch happening. We have x and negative x. Okay? So we gotta get that graphed. Negative x was our function. X is the parent function. Graph it. Get rid of that green crap that's right there. We have a reflection. Look at this. It's mirrored. It's been mirrored from this side over to that side. Some of you are saying, but Miss Visto, it's been mirrored this way. It's hard to tell with lines because of the way that lines work with their slope and whatnot. The reflection could go either way. Okay, especially this one when the slope is 1. Well, a little bit different when the slope is a different number, but here when the slope is 1, it's hard for us to tell. Let's just write that this is a reflection. Okay? When you have your calculator, it's pretty easy to set that up so you can compare the two. Okay? There's one other way we can do these. There's one other way to do looking at parent functions and telling what transformation it is. Sometimes you're going to be given a huge chunk of ordered pairs. It says plot the ordered pairs, identify the parent function, and then tell what transformation happened. So let's look at this first one. Okay? We have ordered pairs at negative 4, negative 6. Whoops, negative 4, negative 6. Negative 2, negative 3. 0, 0, 2, 3, and 4, 6. You guys can already tell that this is a linear function. Okay? This is linear. So we could graph the linear parent function. Oops. And if I could draw a straight line, we'd be totally good. Okay? There's our linear parent function. The blue graph and the green graph start in the exact same spot. They're both at 0, 0. But the blue graph grows faster. Its slope is different. Okay? It's been stretched. We've taken the green graph and vertically stretched it so that it would grow up faster. Okay? So this is, we can say it's a vertical stretch. We see vertical stretch there. That is the transformation that is occurring. Okay, there's one other one here that I want you to try. So plot your function. Plot the points that are used or that are given here in this table. Plot the points. And then tell me what parent function it is, and then what transformation is happening. So you've got it all plotted. Hopefully you can see that this is a square root, or has a square root parent function. And so when we look at that square root parent function, they both start at 0, 0. Then it'd be 1, 1. The square root of 4 is 2. The square root of 9 is 3. So what's happened here? Well, from green to blue, we squished the blue down. It's about half as tall. We can see it's about half because look at where 1, 1 in the green graph, the ordered pair is 1, 1. Here it's 1, 1 half. So we've squished it down by half. Instead of 4, 2, it's now 4, 1. So we have a vertical squish. Now we don't call it squish, we say compression. Vertical compression is what has happened here. And we can say, we can make this a better answer because we know that it's been compressed by about a half. So compression by 1 half. Okay? So you have lots of different ways to deal with parent functions. Identify them, you're just going to have to know. You're going to say, oh, I see to the third. I know it's cubic. That's the thing you're just going to have to be able to do. The graphing, use your calculator. Use one of my calculators. Get a calculator out and graph it. It will be easy if you do that. If you try and think and figure it out that way, you don't know enough quite yet, and so it's going to be a lot more difficult. If you try and plot it by hand, oh my gosh, it sounds like too much work. Your calculator can make things way, way easier. So get in the habit of busting that out and using it to help you. Okay, so get stuff graphed, graph the parent function, and compare, and then come up with your conclusion as to what exactly it took to get from here to there. Okay? Lots of examples here. I hope you did okay. If not, remember, you always ask for help. I want you to do well, especially because last section of Chapter 1 test coming up soon. Awesome.